Fluentd came along quite a few years ago now. It's actually about 10 years old, I think. But let's talk about what it can do and what it is. It's a highly pluggable framework, unsurprisingly, in this day and age. It takes inputs from a vast variety of components, from receiving TCP messages to looking at log files, to SNMP traps, to HTTP sockets, all sorts of things like that. And then it's able to take that information, gather it up, merge those sources together and push them out to different destinations. And those destinations might be things like Splunk, if you want to use Splunk for your security analytics. It could be pushing the data to Grafana and Prometheus to do time series analysis and things like that. And then, of course, just chucking the data into things like Elasticsearch to do analysis in a sort of post-event world. And all of that, of course, you need to be able to format the log events to the different formats that the systems want to consume, lay out the details to make it easy to search. If it's one long string, your querying is not going to be effective. But if you understand the source, then you can apply some semantic meaning. Take a classic web server log and then start breaking it up using an understanding of which web server it's from and saying, okay, well, we know the first number of characters are the date, the next number of characters are the server, and then the last chunk is the message. So you can start dividing that up. So when you put it into your NoSQL or SQL database or anything like that, you can then start to extract the meaning more effectively, more efficiently, which is going to make your life a lot easier rather than trying to write complex regular expressions to search one big string and ignore parts of the message. You can store it, and of course there's an exceptionally good framework for building your own extensions. You can characterize the flow, if you like, of monitoring information into a number of steps. You can look at the information source and capture whether that's a log file, SNMP traps, talking to the JVM, or the other, a Ruby engine, or Growl, or anything else for that matter. Once you've captured that information, you obviously need to structure it and route it to the right place. Structure, as I say, is trying to get some of that meaning, and then you can get into the space of aggregation and analyzing the events. You might even want to filter out some of the events, do some simple counts. How many of these kinds of events have I had in the last hour? And that really all fits to Fluentd's sweet spot. What it doesn't do, but looks to other products to do to focus on, is to leverage them to give you the visualization and the notifications and alerting. There are a plethora of really good tools out there for doing these things, for data visualization and notification and alerting. The community behind Fluentd have sort of taken a step back and said, do you know what? Let's focus on one thing and do it really well, which is the collection, structuring, and extracting meaning from the logs, and then passing it through to something that can then do the processing downstream, such as visualization and notification. And actually our demo illustrates how we can do that in one of many, many ways. You may well have heard, or most people, particularly those working in the sort of microservice world, will have heard of the ELK stack, or ELK. So that's Elasticsearch, that's Logstash, and Kibana together, and they fit into the capabilities this way. So you can see Logstash and its baby brother Beats is doing the log gathering. Then you have Elasticsearch for doing your analytics. It's a data and analytics engine at the heart of it, and of course Kibana to then visualize it. And you might use Prometheus to try and generate time series based data as well. Compare that to what's sometimes referred to as the EFK stack, which is actually becoming more prevalent in the last sort of 18 months, and that uses Fluentd rather than Logstash, and Fluentbit, which is Fluentd's baby brother, and is a bit like Beats in so far as it's a very, very small footprint. So it's great for using in IoT and tiny devices, and its job is just to capture the data and push it out to its big brother, which you might run on a server to do a lot smarter processing of the log information before passing it on into the analytics and search world. They're the two. So if you know the ELK stack, then you can see how Fluentd will fit in. In terms of differences, the key is that Fluentd has a bigger community behind it, and as a result, it's gained a lot of traction in terms of community developed and third-party developed plugins, which means its adoption's become a lot easier. In terms of history, it's become part of the CNCF community, and as a result, through stack drivers, you can see it being incorporated into your Kubernetes-based environment to do your log capture. So any container that spits content out to system out, standard error, will probably end up finding its way through a Fluentd node to be processed into something a bit more meaningful. Compare that to Logstash. It's a slightly larger footprint, but not by vast amounts. But because Elastic have tried to keep a more of a commercial control on it, whilst it's the core of it's free, still the community hasn't developed to the same level of building a lot more plugins. So there's 100 to 200 plugins kicking around for Logstash against the 500 odd for Fluentd. That's not to say Logstash is not a good product. It's a different product, nicely integrated into the ELK stack, whereas Fluentd is a little bit more forgiving and more flexible, but it potentially needs a little bit more understanding, a little bit more work to get it to really sing with the components you choose to work with. The makeup of a log, so every log entry that's generated is given a structure, even at the most basic things. So the log structure goes into what's called the record, but Fluentd, every time it captures a log, will actually associate with it a timestamp of the moment it captures it and sees it, and a tag, and you can attribute the tags based on the source or the technology. And if you get into the details, and then the book explains it, you can start doing some very clever stuff like dynamically adjusting the tag based on what's going on. So you could make it a customer flag quite easily, and as a result you can do things like filtering and routing based on tags, and you can reset the timestamp. So if there's a bit of latency between the log file appearing and when you pick it up, you can reset your timestamp to be the time that the source system was reporting rather than the time you picked it up, and so on. So there's a lot of flexibility, but everything builds around this. You can tell Fluentd to treat the record as a JSON structure, which makes it very easy, if it is a JSON structure, to then navigate through it and start pulling bits of information out. And this comes back to this meaning. And you can actually add information into the record as well if you want. If you want to stop, if you're finding yourself having to do some derived values based on other attributes in the log, there's nothing stopping you actually saying that you're going to insert the calculated value in there as well. So if you wanted to make life easier downstream by putting the difference between the timestamp of when you picked up the log versus when the system thought the transaction occurred, you could calculate the difference and put that as an attribute of X seconds or milliseconds into the record if you wanted to. So downstream you've not got to do that. It makes life a lot easier rather than having to reprocess the event again. It is a more of a declarative syntax than logstash. Logstash looks more like a traditional code with if conditions and things like that. Fluentd is a little bit more declarative, although there is a little bit of sequencing still important in terms of the log configuration, and that's explained in the book, and how to make that not a problem and things like that when you get into really complex scenarios. But you can see here, this is a little bit of the demo we'll run shortly, where we've got some instructions to the system, and then we've got saying we're going to take a source, that source being wherever the logs come from, and then you can create a series of operations that can occur on the logs. And in this case, you can see that we're going to look for an occurrence of a string in the message structure, and we're going to push it to standard out on the way through. And then if it complies with our filter, then we're going to actually push the message to Slack. And this is a little diagram just to help understand how Fluentd works. So it basically takes an input, tries to take it through a series of what Fluentd calls directives, and acts on those directives. And you can see on the right how that lays into the configuration. So let's have a look at my little demo. I have a situation. I have several simulated apps generating app logs. I want to bring them together, and I'm going to apply some output to one of those streams before aggregating them together. And then I might want to run that in multiple servers. So if I'm scaling my environment, I might have multiple servers running the same requirement. Therefore, I want each server to have its own Fluentd, rather than trying to expose all the file systems in each of those servers to a common point and run remote access. So I just put the Fluentd node locally, let it work with the local file system. It's a lot more secure. You're not opening up firewalls or things like that into that node, other than allowing the traffic that's part of the application. And I'm going to forward that into effectively the idea of a central point, which could be running on a separate node. In the demo, we're going to talk about node 1 and node 2. So node 2 is my central point, and we're going to have a common pipeline that's going to filter out some of the log events. Specifically, it's going to filter out any event that's not talking about a computer, and it's going to pump it to standard out, as you just saw in the fragment, and push it on the message onto Slack when it complies. So we'll see in Slack it popping away, telling me about when my simulated log feed is generating a message about computers. And you can see there it goes across the network as it happens. This is all running on my local machine here, because Fluentd is beautifully small in its footprint, so I can fire it all up on one machine without breaking sweat. But you can imagine this is in your network very easily, and this is it will be sending compressed HTTP based traffic across the network between the nodes. If I bring up my Windows shells, as you can see, I have run them a little bit earlier just to make sure that I haven't damaged my configuration. So I'm just going to shut the existing processes down. Right, so 4 screens, node 1 in the top right, node 2 in the top left, and then the 2 bottom shells are running a little tool that's been built. It's open source, that can take a log file and read it and play it back as if it was now in real time, which is a great way of looking at system logs and rerunning them to see what's going on and checking your Fluentd config and things like that, because it looks and behaves just like it's live, but you don't have to run your application. As I say, we've got these 2 consoles with the nodes, and you'll see the Fluentd nodes chattering away on these screens and the log simulator. The log simulator as well, not only can it replay, it can actually generate logs in a structure of your choice, so that you can simulate, config, and just give it some raw data and tell it how to lay it out. So let's have a quick look in my IDE, and I can talk you through the configs. So here's my simulator, and you can see one of my simulators is going to create a message using the format of message. It's going to add an attribute called stream and call it basic file 2, and it's going to add a value called iter, short for iteration, so that as it loops through my simulation data, my simulation logs, it's going to tell me what iteration I'm on, and you can see I can parameterize the values, and I can give it things like thread information. I can create synthetic class path information as well if I'm not replaying a log that's already got that in it. So we have two setups, and as you can see, ever so slightly different. So rather than iter, I've got cycle, and I've got event, and I've got a source, and the paths slightly different, and details like that. Right, but let's look at the all important Fluentd configurations. So this is node 1. As you can see, I've just annotated it a little bit. You can see I've defined a source here, which is going to be a flat file, and I'm going to read 5 lines at a time, and every line that forms a full log will get a log event generated and a tag associated with it. And I've just said, look, we'll give it the basic file as a tag, so we know the source of the event from the tag. And because you want to, when you're looking at logs, you want to track how far you are through it, so that if you want to tune your Fluentd config, you can stop it, restart it, and it'll carry on from where it left off, rather than necessarily going back to the start of the log and reading from the beginning again. And it copes with all sorts of interesting things like log rotation and things like that. I've told it can treat the payload as JSON, because I've defined the structure in my config as a JSON log structure, but you don't have to. You could actually parse it into a JSON structure if you want. And then I'm going to put it into a pipeline, which is a series of enclosed steps called the label pipeline. And that goes down here, and it then says, okay, I'm going to filter it. I'm going to use the record transformer. So there's a bit of debate over whether log entries should be changed or not, whether they should be mutable or immutable. Some will say, a log event should never be changed, because you're changing the truth of what the system said at a moment in time. I've always taken the view that yes, you need a copy of the log event that's as the system represented it, but it doesn't stop you from adding information if that makes your life easier, as long as you know what's been added versus what is original. But in here, I'm just going to grab it and manipulate it, getting the event, the message, creating an attribute in the log event called message, which was called event, and then I'm going to actually just blank the original event. So now my message is exactly the same as my original configuration. So if you look here, in here I've got message as my structure, and over here I've got it as event. By doing that transformation, I can then use the same parsing rule on that part of the payload to do more intelligent stuff. If your system's generating the same information but calling it different things, is a noddy little illustration of it aligning the two to make your next step a lot easier. So when you come to doing your analysis, your queries on the log event history are going to be an awful lot easier if the basic structures are similar. So if I come back here, I'm then going to do two things. I'm going to send the log to my local file, and I'm going to send the log event to my folder mechanism. And here's my folder, and I'm saying every 5 seconds take the cached log events and forward it on to my other node, which is, as you can see, on my local host on a different port. So if we look at the other configuration, which is this one here, you can see I'm now taking my source here is what's being forwarded to me, and I'm then going to go into my common pipeline, which is here, which does a filter looking for messages now because everything is in the same structure, and look for the references to computer or on computer so that I'm not worrying about case. And I've just kept my pattern simple while I'm trying to say look for a capital C or a lower C. There's a little neat trick that Fluentd provides called a filter to standard out, which is effectively just like a printf style of event. It sends the content to the console. Then I have a match, and I am matching it to an output plugin called for Slack. And you can see I provide some details about how I wanted to display it in Slack, which channel in Slack. If you're familiar with Slack as a social medium, we'll see it in a minute. And before anybody gets any ideas, I'll be changing the key after this session, so I don't get spammed to death. So that's my configuration. As you can see, it's pretty straightforward. It's not very complex for what we're trying to do.